Bandwidth for changelog is provided by Fastly. Learn more at fastly.com, and we're hosted on Linode servers. Head to linode.com/changelog. This episode of JS Party is brought to you by our friends at Sentry. Sentry is an open source error tracking application that shows you every crash in your stack as it happens. It gives you details to prioritize, identify, reproduce, and fix each issue. They also give you information to support your team so you can use that information to reach out to those affected. Head to changelog.com/sentry. Start tracking your errors today for free. Get off the ground with their free plan. Once again, changelog.com/sentry. Tell them we sent you. And now onto the show. Welcome to JS Party, a weekly celebration of JavaScript and the web. Tune in live on Fridays at 3 p.m. US Eastern at changelog.com/live. Join the community and Slack with us in real time. Head to changelog.com/community. Follow us on Twitter. We're at JSPartyFM. And now on to the show.
Welcome to JS Party. We're at the party every week with JavaScript. I'm Mikeal Rogers.
I'm Alex Sexton.
And I'm Kyle Simpson.
Kyle is guesting this week, filling in for Rachel. We're going to ask him all kinds of questions about IoT and robots, just to to make sure that he's properly filling in. No.
Put him through his paces a little.
Right, exactly. No. We're not going to do that. We're actually we're going to talk about some very interesting topics that I think we can all get into. So the first one is it's a not contentious topic at all. Nobody has differing opinions about this. This is async flow control.
Yeah, it's very uncontroversial.
Yeah, I mean, there's generators, there's callbacks, there's promises. Pretty much nobody has an opinion about which one of those to use. Everybody does what they want. But let's I just want to get into some of the pros and cons, and also because we have Kyle here who's spent a lot of time kind of writing educational materials. Talk a bit about which ones of these are the easiest to kind of teach, and Alex has a lot more experience in like a bigger company dealing with this stuff, and so there may be like some opposing perspectives there. So, Kyle, why don't you tell us a little bit about this? I know that you have some libraries around this as well.
Yeah, I do. I've been at this async stuff for quite a while. I was just recounting the other day that some of the earliest exposure that I had was the very, very early spec discussions when Mark on the TC39 committee was bringing up the idea of putting promises into JavaScript. He had this E programming language that he has futures in, and he wanted to put promises in JavaScript. And that's when I started following the topic and building libraries around it. And that was probably early to mid 2009. So it's making me feel really old how long that stuff's been around. But, async has been a cornerstone of the language for a really long time, since practically the beginning. But it's a kind of a modern invention that we thought that we should have some higher order patterns for organizing asynchronous code beyond just the callback. And so I when I teach about it, when I write about it, I have to go back to the beginning, because I think a lot of people take the callback for granted. They don't. I mean, you ask most developers, they don't even know why it's called a callback. What does that even mean? And so we kind of have to go back to the beginning and say, well, this is how it was way back in the day. But there is, as you mentioned, there's a ton of really cool patterns that have come out over the last few years. And from my perspective, I think the good part about all of that is more choice allows developers to more appropriately express their intent in their code, make their code more readable.
So when you say way back, are you talking about, dom.addEventListener? And then, jQuery kind of normalized that and made it a little bit more reasonable. Is that what you mean by kind of way far back for the async programming?
Well, some of us were writing async programming before we even fully understood what closures were. I mean, I remember back in 2002, JavaScript was comparatively pretty young and immature at that point. But I remember writing an internal application that ran only on IE4, and we were, or 5 is when they introduced the XML HTTP request object. So you could do quote unquote asynchronous stuff, but we didn't even know what that fully entailed. It's just we wanted to ask for some, we actually literally asked for XML from the server. but we didn't even understand that you could close over a variable and know which request paired with which response. So we were inventing crazy stuff like generating IDs to match them up and things.
So I remember like jQuery when it came out, like a lot of new people just kind of jumped into jQuery and did a ton of stuff. And we're doing all this async programming without really realizing it. Like, Alice, could you give us some perspective on that, since you were definitely heavily involved in the jQuery community during that time? And there were like a million new web developers that came to the web and just started doing async programming without like, doing a bunch of research on monads or anything.
Yeah, it was definitely the case that like being in the jQuery IRC channel at the time, whenever it kind of exploded, like you'd get the paste bin of like a lot of various people's different sites. And generally people weren't doing the same type of massive, large single page application, but it was more like, I need to add functionality to a server-side render page. But like that grew and grew and grew and grew. And so you'd end up with these files, and it would just be one big long set of like calls into jQuery, and then like massive indentation of like, well, if they click on this and then this handler gets called, then this, like, you just like copy and paste, like a clear misunderstanding of like control flow, because it just sneaks up on you. It's like, well, first I can do this, and then I iterate over the elements, and then I change them, and it's good. But like as you start handling more complex actions, like async control flow, and even like a callback's really easy, like real fast, right? But then when you need to wait for like 2 callbacks to both finish, you end up writing like the silly counter logic where like you count up the number of things that have completed until it matches the whatever, like everyone had their own implementations for that. And it became like a well-known like spaghetti case where people had app.js, and it was just one big long set of callbacks inside callbacks inside callbacks inside callbacks. And that, I think, is when people started looking towards things like Backbone. I think Backbone was a direct answer. Not that it solves a lot of that stuff, but just like the structure of those files. And so it wasn't even like an async solution, but it was just code organization and like being able to split up files and actions and like, some asynchronous control when it comes to like models and stuff like that. But I think that's why everyone globbed onto Backbone so directly. It was because like it immediately solved some of the problems with async control flow, even though it wasn't an async control flow thing. It just like split stuff up enough for people to like feel okay again. And then naturally their apps got bigger, and they were like, oh my God, we still need async control flow. And I think we're just getting to the point where people have like solid, like, the kind of the promises revolution and all that kind of stuff is the first time people kind of had solid understandings of like all of this stuff. Back when it was the Promises A and Dominic Tarr and was it Tarr and Dominic?
No, it was Denicola.
No,
it was just
Denicola. Yeah, there was another
Chris
Dominic.
Kowal.
Chris Cole. That's the wizard. So Dominic and like with all the Promises A plus, all that kind of stuff was like right when people were like, okay, we definitely want this set of grab bags of tools, and we should standardize it and all that stuff. And I think that's when the like front end world finally like a lot of the front end stuff actually they got around it in different ways. Like rather than like putting handlers whenever you get data, a lot of the stuff is just like automatically updating. And so it's like we didn't actually solve any control flow async stuff. It was just like the way that we render stuff on the page no longer needs a callback whatsoever. And so like a lot of that kind of got hidden, but I don't know, like it's at Stripe. It's something that we definitely like have very firm like tooling around doing asynchronous actions, and like are constantly rewriting it in order to make it more firm and more solid. And it's the most constant source of confusion and bugs. And like there are so many cases in asynchronicity where like that you have to handle, like loading states and error states and completion states with errors versus completion states that are successful. And there's just so many things that like by default you just think like, oh well, I wrote this code and it'll be perfect every time. And it just adds so much like unknown and you don't know you need to handle that. And so like there needs to be a lot of tooling around that. I don't know. I have strong opinions, but yeah.
So I have a throwback reference that I think at least some listeners would maybe appreciate. And this is a metaphor I use to describe the state of managing state over time. I remember way back in 1986 when the original Nintendo came out, and I still think the best game ever made, Legend of Zelda on the original Nintendo. But one of my favorite parts of that game is, if you remember, the 2D map that you walked around, or pseudo 2D map that you walked around. When you went into a cave, the whole screen went black except for this tiny little illuminated circle around Link where he was holding up the torch. Exactly. And so you could move around to the whole map, but you couldn't see the whole map at once. And that is, to me, what modern JavaScript applications and asynchronous programming are, is that we can understand this one little part. I can understand these 2 or 3 steps of the flow control, but then it forks over to this other part. And as soon as we make that non-local jump, our brains kind of shut off. And as soon as there's any kind of non-linear, if it splits and forks and then comes back together, our brains just don't handle that well. And I think that's a big contributor to why people keep trying to reinvent the wheel with frameworks, is because we didn't really solve one of the core problems, is that we can't, with the language, or we couldn't for a long time with the language, express sophisticated flow control in a way that people are going to be able to read. So we just kept burying those details deeper and deeper inside of frameworks and libraries.
Yeah, I agree with that.
Yeah. So there's been a lot of work that's happened on this over the past, few decades. I'm wondering, we had a discussion a few episodes back about, if you're learning JavaScript today, is there any reason to even learn like the function keyword, or should you just go straight to arrow functions and just be done with it, right? Like when you're teaching JavaScript today to somebody new, like, do you really go back over everything that's possible, or do you just go, look, like here's a way to do this with either async await or with, node standard callback interface? Like, do you just pick one and go like, this is what we're going to learn for now because it's the easiest to get your head around?
I don't think it's necessarily an equivalent thing to like arrow functions to old functions, because like there are times when you still need the old thing, whereas like theoretically you could completely replace the async control flow stuff, or you could I'm not talking any sense. Well, I guess what I mean is that I think you're going to still need to know what a callback is. You may not need to know like all the different ways to like handle callback hell more directly, and I think that's fine. But it's not like you can just like get away with not knowing what callbacks are. It just seems too fundamental, even if you're using promises everywhere.
So people are going to have different answers on that one for sure. That'll have a lot of different opinions among those that are listening, and I'm sure many of my peers in the teaching world have strong opinions on it. Speaking for myself only, I do teach the fundamentals. I teach a course called Rethinking Async, and we start at the callback, and then we talk about why callbacks are limited, and there are several major reasons why they're limited and problems of callback hell. It's not really nesting and indentation. There's deeper problems there. And then we talk about thunks. And the reason for thunks is because they're a really good conceptual base for promises. And the reason promises are useful is because generators can let you do the sync async thing. So I build up from the ground up. Not that I expect that people will write lots and lots of callbacks still, or ever even necessarily write a thunk. But I think those are still really deeply important conceptual understandings for people. So I still teach them.
You kind of glossed over some of the other fundamental problems with callbacks. Like what are some of those issues? Because like in Node Core right now, there's actually an argument about, how do we make promises as good as callbacks are for a lot of the debugging stuff and a lot of the error tracking stuff that we have in Node. There's like a huge amount of instrumentation inside of Node that really depends on some of these structures that aren't there yet for promises. So I'm curious what you feel are the limitations of callbacks. Is it just a composability argument or what?
I would say, to me, there are three main drawbacks that callbacks alone don't solve. The first one is that callbacks, unless you introduce a pattern like a thunk or something with closure, that callbacks don't have any memory. They don't have any way to pair state with them. And managing state over time is the whole thing. That's the whole problem that we're trying to solve. Time is the most complex state in the entire application. And callbacks alone don't have a particularly good solution for that. So people create a lot of ad hoc stuff. They just happen to close over some variable, or some people just still use global collections of variables to store stuff across callbacks. And the callback, you just pass in a callback to a function and latently close over some state object is not good enough for the kinds of complexity that we're typically modeling. The second major drawback.
So hold on. I want to dig into that just a little bit more. I want to explain it a little bit deeper so that some of the newer listeners can follow as well. So when you create a callback, you create this sort of inline function, and if you reference any variables on the top, those get closed over. That's what the closure is. And the VM actually does a very good job of optimizing, like only keeping around references to the things that you're referencing inside of your function. But what you're saying is essentially like the state of the function that it's going to be manipulating is just these variables that are up in the closure, and there's really no way to inspect them, right? There's no visibility into them other than just looking at the code, right?
There is that aspect. You're absolutely right. But I think I'm going at something even deeper. And some of this is that I'm, over the last few years, become a lot more interested in applying functional programming concepts. When you just willy-nilly close over variables out of any scope, and those variables are pointing to state objects that just change because any one of a dozen different callbacks can change them, you're violating some of those fundamental principles like pure functions and things. Now, closure itself is not anti-functional programming. It's actually right at the heart of functional programming. But when you use closure in functional programming, you have to close over something that isn't going to change. If you close over something that is going to change, you're asking for all of the problems that when you look at a function, you don't know how it's going to behave unless you mentally execute the entire program up to that point. But if you do use a pattern where you close over something that isn't going to change, which is what I was referring to with the thunks pattern. If you close over some state and keep that with the function so that that state is preserved, and now the function is the value that you're passing around and reasoning about, and that value that it's closed over isn't changing, then it's really not that much different than a promise. That's why I said thunks are kind of like promises, but without a nicer API. That makes composing, as you said earlier, those different pieces, those functions with each of their different states closed over, composition of those is a lot easier when that state doesn't change. So that's what I mean by callback by itself. It's not a great pattern for that. But when you apply some extra formality around it, it gets a lot better.
Yeah, I definitely agree that even in the promises case, like we're almost always generally adding more state and more process around any async action, to the point where like there's still like fundamental pieces, but like we need things like the actual async action might not be cancelable if it's a promise, but like we need to be able to like cancel some async actions, and like so adding that state, whether something is canceled, and then like preventing things from happening while things are in flight, and extra state around that. So I guess to some extent, like if I'm often wrapping promises in a certain way, then I guess I could wrap callbacks in that same way and manage all that state with the thunk and that kind of stuff. And I suppose that's fine. But it seems to me I always need at least as much state as promises give me in any complex application. Like for sure, I write, 500 line or less programs all the time, a script to do X or Y or Z, and I'm rarely using promises or anything like that. It's just like, I know I need a callback to do a read file, and I just throw it in a callback, and that's fine with me.
And the states that promises have are just success and error, right? Like, but it also says if it's done doing the action or not.
Sure.
Yeah. The done is implicit in whether or not there has been a resolution to success or error. But
right.
As of yet, promises don't have a canceled state. So as Alex is saying, people create sort of ad hoc wrappers on top of promises to represent that particular. And I think there's at least some that believe, and I guess I would probably be more in this audience, that observables, for example, are a better thing than a cancelable promise. An observable already has some really nice abstraction built into it that you can model that idea of it's been canceled or it's no longer subscribed, whereas a promise is kind of a lower level thing and maybe it doesn't need that extra state. So, but Alex, I think your point is taken. that state is necessary. And that's the whole reason why I tell people, look at the pain of all of the ad hoc stuff you have to do when all you have is a callback. Then when you put a promise on, see how much of that you don't have to do anymore. And then when you put an observable on top of that, see how much less you have to do now. It develops a deeper appreciation for those shortcomings than if you just said, well, all I've ever done is write an observable. You're not really sure exactly why, and you're never sure if a promise in any given particular scenario might be enough. The second problem that I believe plagues callbacks is inversion of control. And by the way, inversion of control as a general concept is actually generally a good thing. Martin Fowler says that's the difference between libraries and frameworks is inversion of control. I think that's a good thing. But specifically with related to callbacks, when you wrap up a portion of your code, a portion of your logic in a callback and hand it off to some other piece, whether that's another part of your own app or some other part of the system that you're not in control of, you have given up all control to ensure exactly how, when, and how often that callback might be called. And when you erode that trust, you lose understandability. One of my Getify's laws, if you will, is code that you don't trust is code that you don't understand, and vice versa. So I think that inversion of control problem is a big deal, and promises are actually really well designed to fix that, because promises uninvert that. Instead of me passing a callback to you and you getting to decide when and how often, you pass me a promise and I get to decide if I'm going to subscribe to it, and I know the promise is only going to resolve once. So a lot of those concerns that I might have had about your usage of it, I don't have to worry about anymore. So inversion of control is the second one. And the third one, it's a little softer to describe, but it's essentially that callbacks, the syntax, it promotes a very non-local, non-sequential reasoning. But the way our brains work, neuroscientists tell us that our brains are very synchronous at the highest level of cognition. The way we plan things out, it's very sequential. And callbacks promote a style of programming that is very much the opposite of that. And so I think we struggle to communicate well all the complexity of our flow control because we're limited by the syntactic choices that only callbacks give us. You hear people talk about things like observables and functional programming being more declarative. It's because we can list out a flow control in a program in a much more linear way. My preference is the synchronous style that you get out of async await style functions. That works a lot closer to the way our brains work. And if you can understand the code, you can read the code a little bit better. So those, I think, would be the three things that I consider to be callback hell.
All right. I think that's pretty good. I can definitely say, this has been really enlightening. I think that we got a lot of the good arguments out. I personally will continue to use callbacks because my brain is broken, I guess.
Yes.
It's just better. We're going to take a break now. And when we come back, we're going to talk a little bit about the future of the web and who's trying to kill it.
This episode of JS Party is brought to you by Hired. Hired matches outstanding people with the world's most innovative companies. At Hired, your dream job is waiting to apply to you. Instead of endlessly applying to companies hoping for the best, Hired puts you in control of when and how you connect with interesting opportunities. The best part is Hired is completely free to you. It won't cost you anything. In fact, they pay you to get hired. Head to hired.com/JSParty. Don't Google it. This URL is the only way to double the hiring bonus to $600. Once again, hired.com/JSParty. And now back to the show.
Let's talk a bit about the web. So there was an interesting thread recently from Joe Hewitt on Twitter. For those of you that are newer to programming, did not use Firebug back in the day, a long precursor to the Chrome DevTools was this Firefox plugin called Firebug, and it introduced really the first great web developer tools. That was written by Joe Hewitt. Joe went on to create a small company that got acquired by Facebook really early in Facebook's time. And then Joe would almost by himself write the first mobile app for Facebook, which was actually, in a web container. And he says in this thread that apparently he was in multiple screaming matches with Steve Jobs over email to get that accepted into the App Store. And generally, I mean, Joe, I don't think that Joe has to work anymore. I think that he's pretty set. But he's a really ardent defender of the web. Really tries to make sure that the web is going to win, and really sees it as being attacked on all sides right now, and probably not going to move into the future, and that we're going to move towards more proprietary alternatives because that's what everybody's trying to do. So who is he talking about in terms of attacking the web? Kyle.
Yeah. Well, where do we start? So first off, I didn't follow that thread. Some people that follow me know that a while back I kind of stepped away from Twitter. So I did not follow that particular thread, and it sounds like, just doing a quick Google search, that I'm probably glad I didn't, because I might have gotten myself into trouble with some things I might have said there. But if we take a step back and we just ask, what does even the open web mean? Because probably a lot of listeners would have different opinions on that. But I think the open web means a web where the developers and the users of the web are at least as important in making the decisions for the future as the people who are really making the big bucks, like the Apples and the Googles of the world. To me, that's what an open web means, is a web that we're part of the future of that. It's not just being dictated to us. And if you compare that to, and I'm old enough and been around long enough to remember vividly and have participated in a web where we were just handed the web by what Adobe shipped to us in Flash and what Microsoft shipped to us in Silverlight. That for a long time was like, there's the web that's like the plain HTML pages, but if you really want to build like compelling games or experiences or graphics or video or any of that stuff, you got to go play in this special sandbox that you don't control, that isn't discussed, publicly in terms of how it works. And at any given whim, they can just decide, we're going to change it, mess around with it or whatever. So I think that's the best way to describe what is that open web, is to think about what it was before, when we weren't in control, when we didn't have any say, it was just being dictated to us. We now are in control in the sense that any one of us can participate in the specification bodies, for example. We can go participate in, W3C or WhatWig or whatever, specification bodies for web platform features. You can participate in discussions around TC39, maybe even get invited to one of their meetings or something like that and have some say in the future of JavaScript, because there isn't one company that's controlling any one of those features. So that's a hallmark of a good, healthy open web. But that doesn't mean that there aren't people that want to challenge that, for sure.
I want to challenge just even the presumptions that you've already laid out. So first of all, I mean, we used to, like, Firefox has lost a lot of market share, and a lot of people don't really see Mozilla pushing at the forefront of a lot of new standards because they're so resource constrained. A lot of new standards now are being pushed by Chrome and by Edge. I don't have my numbers for Microsoft and how many people work on Edge, but just Chromium, just the web kind of fundamentals, there are over 500 people at Google that work on it. So they're investing a huge amount of money, but also that means that it's relatively inaccessible to just like dig in and write some code on Chrome and get that out there. So we are sort of reliant on the fact that many Google open web evangelists like really go out into the developer community and pull in feedback, and we're really somewhat dependent on that goodwill effort. On the standards front,
wait a minute. Yeah. We got to give credit to Microsoft Edge, because they're certainly a whole lot more present in that discussion than they ever were before, and they deserve credit there. Yes. And I don't know that we should be so quick to throw Firefox under the bus either.
No. I mean, like they're losing market share, and that has a real impact on how much that they can really do. It's not things aren't looking very great. I I definitely, I mean, like, I still have a lot of love in my heart for Mozilla, having like worked there and really believing in that institution. But like, to say that they're not hurting right now would be, a lie. Yes, I apologize. Edge is doing an awesome job. In particular, they're pushing a lot of kind of offline use cases and stuff like that right now too. So they're doing great work. But I really want to challenge the standards part. Because the W3C in particular has a structure in which members buy seats, and part of buying a seat at a certain level is that you get to veto certain work going in, and Apple has used that pretty aggressively, and it's one of the reasons why we don't have touch standards. It's one of the reasons why we don't have a lot of standards around things that Apple asserts IP in. So we are somewhat limited, but like in terms of like how much we can innovate on the web, we're a little bit limited there.
I think, to be fair, Apple would be able to scare the W3C away from implementing touch standards, regardless of whether they're a member or not. I don't think it was their member status that made that hard. I think it was the fact that they have a bunch of lawyers.
I actually don't agree. Like, I mean, a lot of what we step on open patents all the time in web standards, and one of the things that standards bodies try to do is like get all of those companies to agree to. Yes, they do. Right. Get them to agree to not assert those patents, but there are also outside patents. And one of the things that like you're really trying to do is just, basically berate each of these companies into just like giving up on that.
Yeah, but I don't think Apple would do that.
No, but so Apple has the opportunity to disagree with a standard going out or disagreeing with their patents going into a standard before the standard gets published. But instead what they're doing is vetoing the work ever beginning. And that's really problematic, because then we don't get to see that implementation in other browsers or see any kind of competitive pressure on Apple to adopt the standard. So that 5 years after everybody else does, Apple will put it in Safari or whatever.
Well, I think we'd be better off if more of the web platform could work a little bit more like TC39. And there's some huge caveats there, of course. But I think what's good about parts of the open web is that we can see things like somebody saying, here's an idea for a feature that should go into JavaScript. And any one or any mixture of the browsers can make an early implementation of it to test out. And we've already seen a couple of times that two browsers implementing a feature and saying, we really like this, we think it's compelling, and users liking it has been enough to sway the opinion so that one of the browsers that might have trailed behind or said we're not necessarily liking that feature went ahead and implemented it anyway. So I think that there are still ways that we participate. And I want to just go back to, yes, it's true that there are some mechanisms in place where people's paid memberships do give them some special veto power, but that is still having a group of 4 or 5 players that have a bit of an adversarial setup between them is still far better than one vendor getting to completely decide dictatorial style. So when I say that the web means that we get to participate in it, I'm saying that at least it's not controlled behind some one closed door in a boardroom. There is a group that controls it, and we don't get all that we want, but we get a lot more now than we would have were Flash to be the web that we were building.
Also, I think one of the keys, though, is that you really do want to get rid of that veto power. Like TC39 tries to reach a consensus, but at the end of the day, if they have to, they'll come down to a vote, and each member just gets a vote. And so if you have more members, it decreases the power that any one particular participant has. And I do want to give a shout out to TC39, who runs they own the JavaScript standard. They've done a tremendous job at just improving their process over the last few years. One, in making sure that things don't get certified before we know if they can remain compatible. A lot more participation from outside people and outside groups and developers. They've done a tremendous job at this. And I think that we should probably take some of the cues and some of the processes that they've pioneered and try to port them to other standards groups for the web.
So now that we've talked clearly, we are all completely in 100% agreement on what the open web is and should be. Let's talk about some of the things that are I think, existential threats to the open web. I don't know if I agree with some of the claims that Joe Hewitt would be making, but I'm serving as a co-chair this year of the Fluent Web Conference, which is happening here in about a week and a half in San Francisco. And the theme of Fluent this year is building a better web. So for me, I had to internalize, what does that even mean to have a better web? We have to then think about what the web would be if it wasn't going in the direction of better, what direction would it be going in? And there are several, I think, movements or flows towards things that can rip apart the open web. I think one of those that is almost universally decried by developers is this idea of digital rights protection, DRM stuff, being put directly into the web platform so that vendors get control over the video content being played in a browser or things like that. DRM is these vendors, the content makers.
It goes beyond just video.
Yeah, well, yeah.
It goes way beyond just video.
Sure, but they want control because they want to be able to sell stuff and not have piracy. And that makes sense. They need to make money. But they are biting into one of the fundamental principles of an open web, which is that a developer is completely in control of that experience. And they're saying, no, there's going to be this outside, as you said earlier, this veto power, if you will, that you won't be in control of. I think that
not just developers, but users as well. The users
Sure.
of the open web are no longer in control of their browser.
That's true. That's why Tim Berners-Lee is so vehemently against it, and why he's campaigned so vehemently against it. He created this thing, and he's saying, wait a minute, we need to be worried about the direction that that's going in. But there's no clear right answer here, because keeping it out means that content producers have to go back to the drawing board and figure out a different monetization model than just straight up content access cost. They have to figure out how they're going to account for piracy and other bad actors and things like that. So that's an existential threat to the open web, because that's, to me, that's not just a single step. That is a step in a direction that goes much further, where lots of different people, governments and other people say, well, if Hollywood can step in and control that experience, then the United States government now wants to step in and control that experience, and we want to hook too. There's a lot that road can go down that I don't think we should even open the door. The other big one is ads. That's the big elephant in the room, because again, there's a monetization model that we need to support for the web. People want to build businesses on the web and not just have hobby websites. We need to support business on the web, and part of that is people giving away content, quote unquote, for free, but then showing you ads to get it back. There's some very interesting plays going on right now with what they're doing with the Brave browser and trying to upend this world. But the way the content publishers see it right now, they should be in total and complete control to track your experience. And they'll sort of nod with, hey, we'll personalize your experience so the ads that you get, you'll like. But that is yet another, as a user, yet another control that's being taken away from me. My privacy control is being taken away from me. These are things that I think really do harm the future of the web.
Mm-hmm. I think even just beyond privacy, these ad networks have actually also become vectors for people to do different phishing attacks and things like that, right? So, and not just phishing, but also like getting you to download something and then taking over your entire computer and having that kind of extortionware model where you have to pay them Bitcoin in order to get your computer back. Like a lot of that stuff is actually delivered over these ad networks, because most people, when they put an ad on their site, they don't like do the content deals to get that ad placed. They rely on some kind of ad network to do that placement. And those ad networks are being, constantly scammed by incredibly sophisticated attacks to get these ads in. And so, literally, these are not verifiable. It's not like possible to get them out without just saying, no, we're not going to have ads anymore. Just like it's not possible to protect privacy without saying, we're just not going to allow certain features in the browser that allow this kind of tracking as well. And so, yeah, Brave has been incredibly aggressive about ad blocking and tracker blocking. And as a result, a couple sites, won't work because they're reliant on those features. But if you look at some of the announcements that came out from Safari, and even I know that some of the Chrome people are looking at it, like some of these features that we have in the web that certain sites depend on may actually get turned off because of these concerns.
And maybe they should be, right? Maybe we did put features into the web that sounded great, and then we kind of came back afterwards and we're like, oh, I don't know about that. I mean, I remember, I think one of the classic cases was when you have a link that gets changed to a different color when it's been visited, and then some, enterprising hackers figured out, oh, I can track somebody's browsing history by making links in the background and checking the color to see if they visited it. Well, rightly so, we had to rein back in some of that functionality to say, whoa. Your ability to check on the color of a link is not more important than a user's need to have privacy. And that goes back to the web platform is guided, or should be guided, by this thing called the principle of constituencies. Go look it up if you haven't read this before, but it says, wherever possible, when there's a conflict between priorities, the users come first, and then developers, and then implementers, and way down the list is going to be somebody who wants to track and make an ad more, personalized to somebody. So it's right that we sometimes have to rein those things back in.
I think one of the things that we really need to point out, too, is that the reason why this is an existential threat to the web is that there are constantly competitors to the web, and they're predominantly proprietary competitors. But the reason that the web has always won, and why the web won when everybody was writing Windows software and all of a sudden the web exploded, was that, one, it was more secure, and two, it was usually more performant if you were using multiple applications. Anybody who ran a Windows computer in the late 90s knows that the more that you install software, the slower your computer gets. And if you go to a bunch of different websites, your computer doesn't get slower the more websites that you visit in a single tab, right? And the security model is really, really important, like keeping things secure. You're literally running arbitrary code that just random developers wrote on this computer, and somehow these browsers aren't constantly being taken over. And that is just not the case with desktop software, or with a lot of the software in these app stores and things that we're running. And so the reason why an app store like iOS has might beat the web isn't because people just love their iPhone or there's some kind of experience thing. It's the performance and the security, and we need to be better. We need to be leading the way in terms of performance and security. And if we're not, then we're going to lose out.
There's obviously a huge push to recently, last year or two, and Google spearheaded the effort largely towards progressive web apps to try to bring web apps to parity with native apps. And some people say, well, maybe there shouldn't even be parity. Maybe they really should stay distinct. But there's a big push to blur or erase as many lines between the web platform and the app platform as we can. But I think some of the discussion about that, and about the word performance even, it misses the fact that users, end users, not developer users, but real end users, like your relatives and random people on campus or whatever, there's only a few currencies that those end users really care about. I would argue that end users understand stuff like, this zaps my battery really quick and it makes me have to recharge my device a lot. I'd argue that they understand stuff like, wow, that costs me a lot of bandwidth. That's for people in parts of the world that don't get unlimited bandwidth, like we might get here in the US. And if they're on metered bandwidth, wow, this is really data heavy. Every time I use this app, my data, bandwidth costs go through the roof. Those are currencies that users really care about. And if we want to get to the point where end users care so much about the web versus app platforms that they vote with their dollars, that they buy the web rather than buying apps, we're going to have to speak to those currencies, and not just to the, oh, I feel really good because I can write better code in a service worker. I totally get why service workers are awesome, but an end user is never going to care whatsoever about that. They will maybe care about offline, but there's several steps removed from what we focus on as developers and what a real end user is going to vote with.
Sure. I'd say that it's a weird discussion to me, because we had a time where the web was the leading thing, and it was not a good time. I don't think the web is set up to be a good leader because things are so difficult to change and like in a good way. Like the process for adding or removing or changing something in the web is a lot harder and different than the process for so and so's proprietary application operating system to do so. So I actually find them to be this really good like symbiotic relationship. It's the gut bacteria inside of a human or whatever. The explosion of good fast mobile applications was an absolute 100% driver in quality, good improvements in the web. It is the single most important event that occurred that caused the web to get better in the last 10 years, in my opinion. And I think the web will always be a little bit behind because they want to do it right, and they want to do it in a backwards compatible way, and they want to do it. They have a lot more constraints. And that isn't to say the web doesn't ever innovate. There's plenty of innovative parts of the web. But I think as far as like the edge of what users want, the fact that some proprietary thing can iterate so much more quickly means that the web will always be a little bit behind. And the web shouldn't always just do everything that they do, but it's like a consideration. It's kind of like a testing ground. But I think the web will outlast all of those things, right? Like there will be new types of applications in, augmented reality space that then, blah, 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 are the things that are pushing the web forward in 15 years from now. And so I think it's a symbiotic relationship. I don't think it's a killer. The web just lags a bit.
Are you telling me that I shouldn't build my brand new artificial intelligence virtual reality startup on the web?
I'm telling you shouldn't build that at all because it sounds dumb.
It does, Alex. I think you have a fantastic point. It does really kind of ask the question for all of us to ponder, which is the developers to ponder, is the fact that the web, and especially JavaScript, values backwards compatibility so deeply in its DNA. Something written 22 years ago is supposed to still keep working today. That's always been touted as one of our strengths. But is it a strength? Or maybe it's a weakness? Because I think one of the reasons why we're slow to change is because every time we make a decision, we feel like we're stuck with that decision forever.
Yeah, I think it just causes us to need to create different solutions. Rather than making a backwards compatible change, we make a sister standard that can work alongside the old one. Like there are plenty of ways to store data in a browser that aren't cookies now. And like we didn't have to kill cookies in order to make those work. We were able to make them faster or more secure or asynchronous, like all the different ways that those things are different. We were able to add those things. The difference, I think, is that like when Apple puts out a new like device, you got to get it. Like you can only be one device back, two devices back max before you have a bad time. And I think you can still be on like XP is pretty dead now, but even for a long time, like you could be on XP with a Chrome install and like it would be fine for the most part, right? Like especially since mobile devices were so far behind CPU wise, and if people were targeting that, like I don't know, like
I think the only wrench in your argument is that the Apple Watch is like the number one device that's sitting in somebody's cupboard somewhere. Other than that,
what? Sorry, I'm confused about what that has to do.
You're saying that you can only be one device back, or you constantly have to be getting the new device. And I think that there's actually like a fair amount of fails that happen as well. Like I'm still not convinced with all the VR stuff at all.
Yeah, it's riskier on their end, especially when they have to make hardware. That's a business I don't want to be in. But I guess like the openness of the web and the hopeful inclusion of the most amount of people via the web, like the non-prioritization of companies or Americans or whatever. Hopefully, of course, those things happen. Everyone on the democratization or whatever words you want to use to say that everyone's welcome means that the web works longer for Americans, but it like just works for people who are in situations where they can't have the latest devices and run the latest iOS and upgrade their $700 phones once a year. And so I think it's pretty fundamental to the inclusion, the neutrality, whatever, even though we fall flat in that way, in so many other ways, and like we should always be getting better. I think that's why it's a fundamental part of that, and I don't think we should get rid of the backwards compatibility stuff. Rarely is that the cause of problems. It's the cause of frustration, but rarely is that like the blocker, I guess. It's always just like a concern that we have to work around, and we have, it reminds me of the .mjs stuff in Node. Like that's stupid.
Oh,
and
don't get me on
whatever.
this. Like you're gonna make me go off on a random tangent now.
Yeah, it's stupid and sucks, and like they're the like people who use the bad thing are the ones who should change. But like at the end of the day, like add a freaking letter to your thing and like keep working. It's not like it's an uglier platform because of that history, but like it is not. It doesn't fundamentally break anything, in my opinion, right? So while the web may be dirtier and uglier and have really long names for grabbing selectors, even though it doesn't need to, it's just like that's the web that we have, and like the backwards compatibility is worth the extra characters to type.
We're going to take a short break, and when we come back, we're going to get into our project of the week, which is the first WebAssembly-based project that we've done on the show. Stick around.
This episode is brought to you by TopTal, a global network of top freelance software developers, designers, and finance experts. If you're looking for contract or freelance opportunities, apply to join TopTal to work with top clients like Airbnb, Artsy, Zendesk, and more. When you join TopTal, you'll be part of a global community of developers who have the freedom and flexibility to live where they want, travel, attend TopTal events all over the world, and more. And on the flip side, if you're looking to hire developers, designers, or finance experts, TopTal makes it super easy to find qualified talent to join your team. Head to TopTal.com, that's TOPTAL.com, and tell them Adam from the Changelog sent you.
All right, so the project of the week is Blake2B-Wasm. I'm not going to spell this out. I think that you're just going to need to check the show notes if you want a link. But this is Matthias Boos, one of my favorite programmers in the Node and JavaScript community. But Blake 2, that is a fast, secure hashing algorithm. And this is used in Sodium encryption and a bunch of other encryption libraries. But when they first started talking about WebAssembly, one of the things that they kept talking about was, we'll be able to do these, incredibly fast and efficient algorithms. And so this is actually a pretty discrete algorithm that we need for a bunch of different crypto. And so Matthias has actually, written this in C++ as like a native API or native module in Node.js. He's written it in pure JavaScript so that it'll work in the browser today. And now he's actually implemented it in WebAssembly. And, he's got benchmarks, comparing the three of them. And also, if you dig into how this library is being used, you can see how to pull in a WebAssembly library if your browser supports it today. And still, have plenty of fallbacks and stuff like that. So what do y'all think of this?
Definitely seems like the whole idea behind WASM, like being able to still write in regular web languages. You build your interface in JavaScript and React, whatever you want to do, and then you like have a worker that hits WASM stuff for really complex things like the Blake algorithm or any kind of hashing algorithm would be a really easy choice to do this with. So seems like a perfect use case. It's the use case.
Do we have any idea? I was just taking a quick look at the repo. Do we have any idea what the source language of this is? Like when I look at that repo for Blake2B-Wasm, it just says implemented in WASM. Did he literally write the S expressions, or was that transpiled from some other source language? I think that's the bigger narrative about WASM is what shift will there be from writing stuff in JavaScript to what other languages, and what will that mean for JavaScript?
Yeah, I imagine he took the standard implementation of Blake. Trying to find the thing. I think it's C++.
Yeah, based on the comments, it's compiled.
Yeah. Oh, actually, Blake 2B. Well, there's a Go implementation as well. Could be Go. But yeah, I think it does matter. But in this case, it seems like he
Oh no,
compiled it.
I think he may have compiled, but I think he may have also tweaked it by hand. The WAT file is only 25,000 lines. So.
Only 25K. Well, yeah, but what I'm getting at is that I'm excited about what WebAssembly is going to do for performance. I'm waiting around until we start to see, because I don't think it'll be too long, maybe a year at most, before we start to see frameworks saying, you know what, we went ahead and re-implemented our virtual DOM diffing or whatever in Rust and compiled it to WASM or whatever language they choose. And so it makes a lot of sense to push the most performance-heavy kinds of things into WebAssembly. The question will become, once you've done that, once you've opened the door as a library, as a framework, or as just a company that wrote an application, can you just start making the performance argument for virtually every line of code to where we get to a future where 80, 90, 95% of a web application is actually in something entirely not of the web, if you will. It was written and deployed on the web, but it was written in a more traditional sense. So there isn't as much of that open view source DNA to the web as we used to have. That's the part that I'm curious about. But like you said, Mikeal, Blake to be. This seems like a perfect use case for WASM. I'm glad to see it. It's very cool that we now have all the major browsers on board. So there's almost no reason to not start exploring this space because they all have it. You might as well start seeing what we can do with it.
Yeah, for what it's worth, I think it's written in C. The official implementation is C, not C++. Yeah, I think we're already past the point of view source being super useful.
Yeah. I think that I do want line numbers. I like having line numbers and pulling those up in an inspector and looking at the source. But yeah, literally clicking view source and sorting through the million lines of code in an average application today is slightly less useful.
Or of minified code, right? Like,
oh yeah, I forgot.
Like, I think we're already doing so much compilation that like the compilation view source argument is already moot. Even though like we just need better WASM decompilers. Like in the same way we can pretty print the minified code of a Webpack compiled React application that was also transpiled with Babel and like somewhat backwards figure it out. Like that exists. Like decompilers exist for most languages, and like we could reverse engineer the C in this and then like get a similar thing. You just have to read C. So I think like the fact that we do this more is only because we used to do it a lot. And I don't think it's a bad thing that we do decompilation to figure out how things work. And like, there's still no like fundamental like thing that makes that illegal on the web, even with WASM. It's just, we need new tooling. Like there's no reason dev tools couldn't implement like a WASM decompilation view for like, minified or precompiled WASM. So yeah, I'm not sold on the idea that like, we're going to break the web by having compilation targets. But I'm also not necessarily sold that at any given time that like more than a small chunk of people will be wanting to write in C. Right.
Well, maybe not C, but I think there's probably a pretty significant chunk of people in the Node ecosystem that have at least considered writing parts of their Node applications in Go, for example. That seems kind of a natural bridge, and many high-profile
they have that option.
moved there. So, but they have that option, of course, now. But I'm saying they could have the option of not even moving outside of the Node ecosystem. Node, if V8 supports WASM and Node supports that, you might potentially see people writing Node applications with very little JavaScript.
So I don't think I've ever seen it with Node. I've seen it with Rust a bunch though.
Yeah, but why wouldn't like I guess on the server, people already have the option to do whatever they want. They can just write their whole application and go with Go server. Like we already see this choice being made by people, and people still choose to write in modern JavaScript, right? Like I don't think, I'm not saying there won't be websites that are completely written in other languages, but I don't feel like people choose JavaScript because they're forced to only. I think people like it, and like as it improves, it will have the things they need to not want to switch. And if it doesn't, then good. Like there's no reason to hold on to JavaScript just because we all have fond memories of Ajaxy in 2009 or whatever. If it gets beat, if it gets beat as the best thing, and it's compatible in a way that makes the web principles not break, then cool. I'll be the first to switch over to it, but I don't think that's the case.
Speaking of JavaScript, the language progressing, I did find it interesting that just apparently at the most recent TC39 meeting, we saw another, and I say another because I keep track of where proposals are, and this is at least the second or third one that made it all the way to stage 3, which ostensibly seems like, hey, this thing's going to land in the browser, or in JavaScript, and then they pulled it out, and the latest victim, if you will, is SIMD extensions. And it seems like the story is, hey, we don't need SIMD in the language because now we have WebAssembly. So in some respects, that's a shame because I was kind of looking forward to that and I was excited about it. But in other respects, I think what's good, Brendan Eich described this a couple of years back when he first talked about WebAssembly, that it could sort of be a pressure release valve on the tension of wanting to put so much stuff into JavaScript, the language. Right. Maybe what we'll start to see is the JavaScript, the language, can improve in readability and not necessarily have to improve in adding all these new hyper performance optimized APIs.
Yeah, I think it's silly to think that like JavaScript was going to be the best way to do things whenever like SIMD was like simultaneous operations on a CPU is like not the level that I think most people want to be building websites in. And so if your website needs that, then like it's likely that like there is a better choice for tooling and all that kind of stuff that exists in JavaScript. So I think that pressure release valve is good. I kind of wish there was still, it still existed because like for the most part, like as long as it doesn't affect me, I'm glad it exists. But like, I don't know. I like that pressure release. Is it definitely a good way of thinking about it. The Brian LaRue's of the world who are very against adding anything, I think will also appreciate it because there definitely is pressure. Like we can't do X and Y and Z that everybody can, or like how come we can't hit the right frames per second and all the other things can? And it's like, well, those are built to do those types of operations, and like globbing that on to a language that wasn't built for that is like maybe a bad idea. And like I'm okay if you're doing things that need simultaneous CPU operations. Like use the languages that were made for that, and that's fine.
One interesting little thing I find in here is that if you look at the benchmarks, I mean, the WASM implementation is doing really, really well. But the native module in Node.js is actually still, quite a bit faster.
Of course.
So than what's going on at WASM. So that's kind of interesting. So it's not a, there may still be a really good place for some of these primitives to make their way all up into JavaScript, so we can do some pure JavaScript stuff and eke out some more performance without crossing that barrier between.
WASM's still pretty early though.
Yeah, that's true.
One of the things that surprised me, it didn't get a lot of fanfare and hasn't even been talked about much, but reading the release notes for ES 2017, they just sort of slipped in that final bullet point that they added atomics and shared memory, which is essentially threaded programming, a very light version of it. But for 22 years, the main selling point of JavaScript is it's single threaded. You don't need to worry about mutexes and semaphores and all that other kind of stuff. And now the pressure point with web workers and sharing memory between web workers was enough that feature has now landed. I'll be curious to see whether that one pulls back because we move in the WASM direction for threaded programming, for example.
So I would not compare this to threaded programming the way that most people understand threaded programming. It's much closer to like the message passing structures that you might find in Go and things like that, to be honest.
Well, they literally do have mutexes. The atomics thing is
right.
block an API, block on a read until it's all right. Now, I know that's CSP-ish like Go, but it literally is, hey, I don't know whether or not I'm the first one to read, so block on it. And I don't know whether the intention is that's the only API, they just put that very bare bones thing in and there won't be any more, or if that's just the gateway to lots more sophisticated threaded stuff coming to the language.
Yeah, I don't know. I think it is actually pretty important even in the JavaScript world to be able to share memory between workers, though. Like, you could be completely in JavaScript and still want that and still have that be a very good performance increase that like isn't super like CE, other than the fact that like it's just like the memory is tough to manage when you can't manage memory, and like workers are a natural place to like offload things, but if you have to duplicate all memory every time you have a worker, it kind of ruins the whole thing.
And on that note, let's get into our picks. Alex, what's your pick this week?
My pick this week is Blake to be WASM.
Oh no, we totally messed this up, man.
Was that your pick too?
If you need to think of one, we can go to Kyle.
Yeah, I'd like to hear what Kyle has to say.
Okay.
Well, I have to pick this week the Fluent Web Conference coming up on June 19th and 20th and 21st out in San Jose. I am, as I said earlier in the episode, co-chairing this conference, and it is not too late to get in. We have plenty of seats open at the conference, and we also have seats open at our training workshops. I personally am somehow also doing a class there, in addition to trying to co-chair the conference. But we'd love to have you out at Fluent to continue this discussion of what it means to build a better web.
All right. So for my pick, I've done a lot of bread-based picks on here from my bread making. As a result of doing that for several years, I'm a bit overweight. My cholesterol's terrible. So I've made some pretty huge dietary changes. I'm on a keto diet. And the one product that's just been like really saving me and helping me kind of stay in ketosis is this MCT powder by Quest. So you can get it on Amazon, Quest MCT powder. If you're doing a keto diet, it's the best.
That was an interesting pick. My
Alex.
pick, my pick is not dietary supplements this week. It's Preact.js. So we've talked a lot about React, and I reach for Preact occasionally, especially for third-party type things. So if you're used to React and you need and you really don't need very much of it. Like it's definitely not like API compatible or anything like that. But if you remember in the old world, there was jQuery, and then some people had some jQuery Lite versions. I can't even remember what they were called. But Preact is just like a 3 kilobyte implementation of some of the most familiar parts of React. And so if you need like a little widget and you don't want to like start off with 40K and pull in Redux and all that kind of stuff, like Preact is a pretty good choice, and we haven't really talked a lot about on it. There are a few other like 3 to 5K implementations of React, and you can kind of probably find some comparison charts and things that people like about the different ones. But Preact's a good choice. The other ones are fine too. But I find that a lot of people pull for React, and the only thing they want is a render function and like the change event to work the way that other things work, and then the other 39K is just relatively unused. So Preact.js.
Nice.
There's a good talk from JSConf.eu, Into the Void 0. Preact by Jason Miller.
Sweet. All right. On that note, that'll take us out. Thanks everybody for listening, and goodbye.
Bye, everyone. Thanks, Kyle.
Yeah, thanks a lot for having me, guys. I appreciate it.
All right, thank you for tuning in to JS Party this week. Thanks also to our sponsors, Sentry and Hired. Also, thanks to Fastly, our bandwidth partner. Head to fastly.com to learn more. We host everything we do on Linode servers. Head to linode.com/changelog. Check them out, support the show. This show is produced by myself, Adam Stakoviak, and edited by Jonathan Youngblood. And the awesome music you've been hearing is produced by the mysterious Breakmaster Cylinder. We do this show live every Friday at 3 p.m. U.S. Eastern, noon Pacific. So join us at changelog.com/live. Slack with us in real time. Head to changelog.com/community. We'll see you again next week. Thanks for listening.